Hello, everyone, and welcome back to Code with the Italians. Today, besides the fact that Ivan and I are melting because it's getting hot in Italy now, we're going to be talking about Compose Compiler with Amanda. Hi, Amanda. Welcome. First time here. Hopefully not
Hey.
last.
Well, thanks for having me on. I'm really excited to be on today.
So, do you want to briefly introduce yourself before we let Ivan do his thing?
Oh, yeah. For those that don't know, my name is Amanda Hinchman Dominguez. I am a Kotlin GDE. I also help run the Chicago Kotlin user group. I'm based in Chicago, and also co-author of Programming Android with Kotlin, Achieving Structured Concurrency with Coroutines, and I specialize in Kotlin metaprogramming in Android.
You are the Kotlin compiler person, for what I'm concerned. If I ever have a problem, well, I don't know if I will ever need to, but if I ever need to deal with the compiler directly, you're the person I'm gonna ask things to.
Yeah, pretty much.
Ooh, yeah, it's a.
And I hope I can do the same without still not understanding anything from what you are gonna try to teach me, because compilers are hard. So, but
Yeah.
I'm happy that I can ask.
Yeah, we'll see how much we can get through. Yeah, that's the fun thing about the Kotlin compiler. There's no documentation, and it's a whole lot of poking and prodding for me.
The documentation are the friends we made along the way. No, wait, what was that?
I don't think it was the exactly like that.
Something along those lines. Come on.
Yeah, kind of.
I'm gonna start telling everyone that.
You're free to use it. So before we get into the actual Kotlin compiler, Ivan, go for it.
Yes. So welcome everybody. As a public service announcement, we won't have the bot running because I broke it. Okay.
When did you break it? When did you have time to break it, man?
I actually did something on my Windows subsystem for Linux kind of thingy, whatever, because I'm doing some Node. I broke it, so it won't start. So please bear with me. Come on. I mean, I'm doing too many things at the same time.
Should I buy you like a server to run it on, so you don't have to run it on your machine?
Well, now that you mention it, I can deploy. Hello, hola a todos. Gracias,
no.
Mark, por comprar el Ivano. Bienvenidos a Código con los Italianos. Bienvenida, Amanda. I need to speak Spanish because of Mark Ellison. Si te gusta las camisetas, but this is actually we don't sell this, so no, scratch that.
No.
Too bad.
So we don't sell this one. If te gusta comprar la camiseta de la pizza,
Even it's
check
fine.
our
It's
tienda
fine.
de ropa. Yeah, it's too hot. It's too hot. So if you want to support us, you can buy keychains, you can buy the metal pin, you can buy the pizza t-shirt, and the YOLO t-shirts. They're actually super nice. And if you have an Amazon Prime subscription, you can connect it to your Twitch account, and you can subscribe for free to our channel every month. You will see that something like subscribe with Prime appears, and you won't be charged anything, and they will allow us to keep printing and selling and sending the stickers to our supporters and giveaway winners. It was harder than expected.
It's the heat. It's the heat. I literally have a fan here. It's at arm's length. It's like just barely outside of my reach. So I can at least survive until the end of the stream.
Yeah, this is gonna be fun. Anyway, thank you everybody, and let's start, Sebastiano.
Yes.
How
So,
to do this?
well, as we might have mentioned already, we are going to be talking about the Kotlin compiler. I think maybe a good start would be, Amanda, to cover why you got into the Kotlin compiler. Like, it's not something that people just do. So what happened to you?
Wow.
Why did you put it like that? Because yeah, when I started doing computer science, I was definitely like more of a punk back in the day. You know, just angsty, like, why would I care about this? You know, like, yeah, I didn't think I was, I don't think anyone really gets into compiler work on purpose. You just kind of fall into it. I had an interview with Hoyen at Kotlin Conf, and for some reason I was like, oh yeah, metaprogramming is the gateway drug to compiler work, and I I don't know why I said that, but it's true. It's true. I started out doing front end. I actually, so I'm an Android developer right now, and I didn't always do that. I started with like kind of front end work back in the ASP.NET days. I
Oh,
know that's
wow.
still around. Yeah, it was a different time. I was like in Florida, and I didn't think tech was for me at this point. So I started getting into like JavaFX because it was just kind of like a fun little desktop application. I don't know if anyone uses JavaFX for anything. It's just kind of a niche little, you know, I like it because it's like, you know, if you're on the crazy side of things, you're like, there should just be no internet. And sometimes I feel like that. But yeah, it was great. You know, someone suggested like years ago, they're like, hey, there's like a Kotlin overlay for JavaFX. So I started playing around with Tornado FX, and that's still like one of my favorite frameworks to this day. And this is how I like kind of discovered Kotlin. I was just like, oh wow, it made such a huge difference. Like you could write, you know, like 50 lines of, or instead of writing 50 lines of code for a function in Java, like now it's like 5 or 10 with the DSL. Pretty sick. And it was kind of funny because, you know, I found this Kotlin community. There was like this super sick Slack chat. You know, you just ask a question at any hour, then like 5 people jump in, and you don't get that a lot in tech communities. Yeah. To this day, I don't think I've ever asked a question on Stack Overflow. You know, I'm just kind of terrified too. But yeah, I don't know. Yeah, so I went to Chicago because I actually heard there was like a Kotlin scene here. Started doing Ruby on Rails, full stack. That was a fun time. Sorry, quick asides, like Chicago's kind of interesting because it's like a newish tech hub, and like 5-10 years ago it was like huge on Ruby on Rails, so that was like all the trends at the time. Yeah,
Ruby
but
on
that's
Rails, wow.
I
Yeah.
Well, I have fond memories because I was using it at university. I was like the nerdest of the nerd because everybody was using Java and PHP, and I came up with Ruby on Rails because Active Record was cool and was easy for database stuff. Yeah.
Yeah.
And then
I
Such
was
easy spin
I moved.
I was assuming that about 10 years ago was already like not as popular anymore. Because I remember it was very popular like in the mid-aughts, something like that. Because it was one of the early ones, right?
Yeah, it was one of the early ones. I would say it was popular for its quick spin up and low cost for spinning it up. So there was like a lot of startups out here. Like now there's like a lot of big companies out here, but back then it was just all these small companies. So
Right.
everyone did Ruby on Rails. And you're 100% right. It should stay as a POC. I don't know if it's intended for scalable work.
I guess people these days just use Node instead, which is
Yeah,
somewhat
fun.
the same level of difficulty, but it can be somewhat made to scale up.
Yeah,
So
it's a little bit better on that. Yeah, well,
anyway,
right,
that
so
was a tangent.
yeah, sorry, got a
No,
little
no, no, no.
distracted, but
It's just
it is what
interesting.
it is, you know?
It's always interesting to find out people's story because it it shows that everyone's journey is different and everyone gets to different points at different times in different ways, and
Yeah.
it's always fascinating to me.
Yeah, no, I love asking other people too, because oftentimes by the time we hit this conversation, it's always great to know, like, you know, like where were you before? And because I'm sure like not all of us did Kotlin and Android forever, you know. When I moved to Chicago, it was like at that time, I think there's like 16 people in the Kotlin group, and it was like all the fans, you know, like it wasn't even like a job choice, but now it is. So it's been great. Yeah, like there was a meetup recently where people were like, "Are you doing Kotlin at your job?" And they're like, "Yeah, I'm doing Kotlin at my job." "Are you doing Kotlin at your job?" They're like, "Yeah." So it's really fun. But yeah, I fell into Android right after that, like at the company. They're like, "Hey, you know Kotlin?" Normally it's the other way around. You learn Kotlin after you've been doing Android for a while, so a little bit inverse for me. But yeah, at the time, I just kept playing with Tornado FX. There's a lot of metaprogramming aspects around it. Actually, Kotlin offers a lot of language features that relates to metaprogramming. You know, for example, there's like, I mean, there's a lot of common ones, especially around the JVM. So there's stuff like AOP, you have, of course, reflection, maybe some versions of code generation, and Kotlin takes it a little bit further with some of their language features like reified generics. So some really cool stuff. I think I was just so impressed with how little code. I'm like, how is this even possible? And then you lift the hood up, and then you look at everything, and you kind of close it because you're like, I don't know what any of that is. Not emotionally mature enough yet.
I mean, I can imagine looking into any compiler is gonna scare the crap out of most people.
Yeah, it would. I think when I've heard people like in college looking into it, I just like did everything to divert away from it. But sooner or later, I think a lot of us will run into something that ends up touching the compiler. So, for example, there is a link. I don't know if, oh yeah, the Tornado FX suite on the link tree. That was a project that kind of forced me to fall into the compiler by accidents.
So this one,
Yeah,
the
that one.
Tornado Effects suite.
No way.
I think that's the
So
problem.
unfortunate. Here, let me
Fixed.
see if I can.
I fixed it.
Oh,
It's
oh,
just
okay.
it's a double URL. You probably pasted it twice.
I
Either.
probably did.
It's
Thanks so much.
alright. It's alright.
Happy the best of us. But yeah, this is like a fun little Tornado FX thing, and I'm not sure where I got this idea from. I think at some point so it actually started with I was creating like a drag and drop application with Tornado FX to generate XML, which is actually like one of the lowest forms of metaprogramming. I was like, oh man, like it's not that smart. But what I was trying to do was create some automated UI validation by being able to pick up the UI elements like buttons and text forms and stuff like that. And this is kind of how I accidentally fell into it. You know, there's a couple different ways you can approach this problem. Trying to pick up UI elements in particular. I know a popular one for a lot of places is using AI, like image classification. What I went with required a lot less power, which would be going through the source code, in particular, like the classes that we know are like UI classes, and being able to parse out the UI hierarchy through. And there's a couple ways you could do this, but I actually use this. There's like a cast tree library. It's like super old. I think actually Kotlin offers something more modern now. But yeah, cast tree. I think that's like another link in the link tree because I think it's fun to play around with. Also, I'm
Castry.
gonna,
Yes.
yeah, yeah, this one, like, there's a couple other libraries that I think stand side by side around AST objects. So AST stands for Abstract Syntax Tree. Abstract syntax trees are basically, so like, let's say that you look at your code
Sorry.
and no worries, no worries. So you have your abstract syntax tree, and what that is it describes how your code looks. That's all it does. Like, this is like actually one of the first steps of the Kotlin compiler. So I actually didn't know this at the time. Like, all I was just trying to do was just be able to parse out some stuff, and it was kind of neat. I'm gonna go ahead and like put in a link in the chat. Oh, okay. There are rules. It's very nice. Oh no, they won't let me verify my account. I'll just put it in the Skype chat.
You can, yeah, drop
I'll
it
copy
in
paste
Skype.
it. Can you copy paste it, Ivan?
Yep.
Yeah. So in the meantime, Amanda, I'm curious.
Yeah.
Is there a specific reason why you ended up using Castry instead of, say, using the built-in PSI parser or the UAST?
Oh yeah, there was a reason. I think, what was the reason for the, let's see, the PSI? There was a reason. Actually, AST and PSI, they're kind of similar. They're not exactly the same, but they kind of are when we're talking about Kotlin in particular. So actually, if you look at one of the imports, at the top, there's like import cast.ast.psi. So yeah, usually when I talk about steps in the compiler, which I think we should probably go over in this chat.
Yeah, probably.
You know what? Maybe we should like kind of quickly go over that. We could do like a quick derivation or something. And I know there's like a lot of these. You know, I thought it'd be kind of fun for folks like watching this. We can like look at the evolution of drawings I've made over the last few years, because I never even like fully got into it. But you know, to make a long story short, after I started looking into the AST stuff, I started working on Arameta, just because they were running into similar issues with parsing out PSI in particular. So when we talk about AST and PSI is used synonymously in this discussion, but we can talk about like what exactly is the difference between that. It's mostly that PSI is Kotlin specific. It's like an overlay that determines the grammar for the AST, because the AST is simply just like, okay, here's like some tree, but the PSI is like kind of what determines the rules around what all.
Maybe another small note to that is that PSI is the internal code representation that IntelliJ platform uses. So when you type in some code, in order to be able to do the highlighting and understand what's where, do quick fixes and stuff like that, it parses it into PSI, which is, in this case, a sort of AST. So it's more of a working representation of the abstract syntax tree of the language that you're using.
Yeah.
Complicated.
Yeah, I know it is a little complicated. Like maybe we can think of AST as more of like a general compiler concept, and then PSI being more specific to the IntelliJ platform. And kind of a fun fact, like, I don't think, unfortunately, we won't be able to compile any Kotlin code today because it only works on my Mac computer at home. Seb and I were talking about this. Apparently, you need Java 6 and Java 7 to run the Kotlin compiler. So a bit of a pain. But yeah, so yeah, I would say the long answer is for Castry, it does kind of use the PSI. But yeah, let's talk about the brief steps, and we'll definitely come back to all this. But you know, the kind of fun thing about these iterations is I don't think too many of them were wrong. It just kind of became more detailed over time. So yeah, for those who are not as familiar with the Kotlin compiler, also definitely feel free to put in the chat how much experience you have with this discussion, so I know how much I should give detail on, stuff like that. But I'm going to assume, from a beginner standpoint. So when you compile code, you input your source code, your Kotlin file, your Java file, whatever. And it's the Kotlin compiler, like, it's super smart, but it's also not smart. What it does is it'll start with breaking down the words that you have. Okay, 0%, say no more. We're going to go to the common denominator.
I like that. Makes me feel smarter.
Yeah.
Oh, by the way, that's my ghost account. That's me. I'm kidding. No, but I share the 0%. So.
Yeah. So when you compile source code, it starts with breaking down the text that you have on the screen individually. So it starts taking everything down into individual tokens. So it'll, like, let's say you have something like val num equals 2. Val, num, equals, and 2 all become tokens. So they all become these specific tokens, and at the parsing stage, you have syntax analysis, and then in resolution, you have semantic analysis. So there is a difference between the two. Syntax analysis is what puts together that PSI tree, and there's some of that, like, grammar, that context-free grammar that we're talking about. So we have this PSI helping us define how that AST tree looks, and that AST tree is going to be made of those tokens. So we put all that together. Oh, beautiful. It's so much
I
easier.
just realized that slides, it's easy.
Yeah, and also the nice thing is, as we start rating all of these, as you can see, it's like not crazy accessible. It becomes less accessible over time, and then at some point, Louis was like, Amanda, you got to fix this. I'm like, you're right.
At some point, it's just mad scribbles on the wall with red yarn joining the bits together, right? It's like conspiracy. Ah!
That's literally what this talk is. Like, it's just like conspiracies talk, like Sylvie and Pepe, like. But yeah, so you have your
Aliens, man.
Yeah,
Aliens.
man.
Oh, no spoilers.
Oh. Well, we can get into it at some point. But yeah, so, this whole bit where we're just like we're picking up the PSI, like the automated UI testing. So picking up all those UI elements, we literally only hit the second part of the entire compiler. And that's kind of the cool thing about the Kotlin compiler. You don't need to use all of it to use it. So for example, there's kind of a fun distinction. Kotlin, the entirety of the Kotlin language is made up of plugins. So if you look at, like, the Kotlin code, for example, which maybe we will later on, but it's just like literally it's so dense and hard to navigate. We may or may not. It depends on what the audience wants. So you'll have like portions of like the Kotlin code, you'll have different compilers, which we'll also talk about. And then there's also different kinds of plugins. You can have compiler plugins, which can run through the front end of the compiler and or the back end. And then there's also IDE plugins, and that is much of how Android Studio and IntelliJ both works. So for IDE plugins, it'll run through just the front ends and then send off different sets of synthetic descriptors and other information, which helps the IDE kind of like get information that it needs to be able to react to it. So the compiler touches everything. So kind of cool, kind of neat. And yeah, I think that is, yeah, so I spent quite a bit of time touching the front end of the compiler. And then actually, if we go back to that link that we dropped, the cast tree, no, it wasn't the cast tree, it was the Tornado FX K parcel impl.
That was the code, yes.
Yeah, there's like a class. So quite literally, I had no idea at this point that I was like messing with the compiler. I mean, I think like I didn't understand what I was doing at the time, and quite literally it was a bunch of poking and prodding. Like I would just kind of break it down, and then it would crash. I'd find out why it'd crash, because I mean, to this day, I don't think there's a lot of common knowledge on what all the PSI. Well, that's okay. That's false. That's a lie. There's actually now documentation on that stuff, which is great. I don't know where that was when I was doing this.
I
But yeah,
suspect it might be recent because JetBrains has been working on documentation a lot in the past 2-3 years, but there was essentially none in the past.
there was none. There was none. It was all poke and prod. And thankfully, like, yeah, there are some there's like a PDF that's like a couple hundred pages and it's like in detail. It's amazing. It might
Damn.
be, yeah, there might be a link sitting in the crash course portion of my GitHub stuff. But yeah, if you kind of scroll down, it's kind of fun to see because you can see like the node function decal, and then everything starts breaking down because when you break down AST, it starts with the Kotlin file, and then you go to like the class, the members, and then members within the class. Then you just kind of keep breaking it down further and further, and it's kind of recursive over time. So yeah, it's kind of like some fun patterns, I think, to learn. And I personally feel like for anyone that might be interested in getting to know the Kotlin compiler, I do think this is probably one of the easier ways to kind of get an understanding of what's going on. Because if you ever wanted to do something like write plugins yourself, you're gonna need to be familiar with how the PSI works, because this is ultimately the first form that the compiler will do. Whenever we talk about compilers, it kind of does two things, you know, so it's a gross oversimplification, but I like to think of compilers as either compiling the data, which means the format of the data changes. So we've been talking about AST, PSI. We started with source code, we went to tokens, and now we have this PSI. So that's some kind of compiling. And then when we hit semantic analysis, that formats or lowers the data. So there's a bunch of formatting and there's a bunch of lowering data. So you go through a couple different transitions of this. But yeah, this is like one of the first steps. And eventually this changes to IR, which is intermediate representation, is something that the compiler can better understand. And from there, it will transform the code again into whatever the target code is, whether it's bytecode or bitcode or whatever.
So I guess we are now, well, we kind of explained this because we talked about IR, right? Maybe we can cover the role that IR has in the process. And maybe if you do know why it's needed, then that's also something I'm curious about.
Yeah, that's a great question. So let's talk about IR. So IR stands for intermediate representation. And I think, what is the need for all this? I guess, okay. I'm like, I hope I can do this in a very concise manner, but yeah, well, remember we have like the PSI tree, and then we talked briefly about semantic analysis. So the reason why semantic analysis happens is because when we have our PSI tree, we actually don't know, like, okay, like the code looks right, but we don't know if the code actually compiles. We don't know if the code is actually correct. So what happens in semantic analysis is that it will analyze the PSI tree that it had put together, and it will infer a lot of additional information around that. So what usually comes out of that is some kind of context binding and also descriptors, which contains additional information like, what's like the parents of this, like, is this part of a set? Where's this stuff coming from? So all of that will, semantic analysis will give you all this extra information. And just a disclaimer, if since we're looking at this particular one, I learned later on Things change dramatically in the Kotlin compiler. I'm sure some folks hold there's like a K2 compiler. So everything we're looking at right now is K1 related. Because we'll talk about some of the additional differences with K2, but I think a lot of this discussion is still true for K2 as well. So yeah, semantic analysis will analyze the tree over again to create all that additional information. And then when we transform that information to IR, that becomes like a different data structure for the Kotlin compiler. It makes it easier for the compiler to be able to add additional information in the backend that relates to heavier computation. So for example, once we send that unoptimized IR to like the backend, what it will do is it will start analyzing it and creating things like a call stack, control flow. And once we get to like the backend, we start talking about CPU optimizations, even like coroutines and multi-threading. So there's a lot more strenuous operations that go on in the backend. So that's why we kind of have this like data transformation, because a lot of that stuff can be simplified. So for example, we change all that PSI to IR, like now it means something to the compiler. And what it can do from that point, it's a bit more simplified. So it's harder for us to read at this point. It's easier for the compiler to read. And it will take existing operations, and this is actually going to be a little interesting. I might show some examples of what these data transformations look like at the end. Because like if we talk about Compose, for example, they actually do some really crazy stuff that is not the usual intended operation for the compiler. That's kind of the cool thing about writing compiler plugins. You can alter the behavior of all this, but what we're talking about right now is default behavior for the compiler. So default behavior, you send it that unoptimized IR, and you're able to simplify existing operations. So the most common one I use is like, let's say you send over like 3 to the power of 2 in your code. In the backend, it's going to change that exponential operation to 3 times 3, so that it's a lot easier for the bytecode that's created to kind of be created that way, because the compiler like needs to rewrite some of these operations so that it's a lot simpler to execute for the compiler. So that's why all this IR is needed. It's an additional data format that takes originally in the K1 compiler all that, the PSI trees, the context, the binding context, the descriptors, whatever else, and it changes all that into like one single data format so that it can execute all that stuff. I hope that makes it a little bit clearer. And the generated IR, like the PSI, is also a tree. It's also a tree, and it just like contains all that semantic information that was generated previously in the resolution step.
I think Ivan has a question. He raised his hand.
It's more of a comment. Can I state the naive and obvious? That's a lot of pieces. It's a lot of stuff.
There's a ton of steps. I agree. It's a lot, and actually, I'm kind of glad you pointed that out. It's not naive at all. I mean, even at JetBrains, the guys who work on the compiler team, oftentimes, like, if they're working on the front end, they just stay there. Like, there's like a whole separate side for backend because the code is so large. It's the compiler is very big. K1 previously, I don't know if you all remember, but there were some complaints for some time about IntelliJ kind of running slower for a while. So that was like some of the reasons why they were motivated to move to K2, the new front end compiler, which runs some things a little bit faster. So yeah, this is the code we're talking about is crazy big. Maybe I will share the screen at the end so we can just get an idea of how big it is, because looking directly in the Kotlin compiler is the most unfriendly thing I've ever looked into. It's given me grief.
Is
I'm
it-
sure it's given
Is it kind of like if you stare into the abyss stares into
Yes.
you, or?
Yeah, at some point the compiler looks at you, stares back at you.
You start seeing visions, and there's these ASCII art eyes that follow you around.
That's kind of
And then
what
you
it's
wake
like.
up.
I feel like it sees me
And then
more
you
than I
wake-
can see it. You feel kind of exposed looking at it because you're just so lost in there. Yeah, no, I think maybe that's what we'll do when I share the screen at the end. We'll just take a quick look and just be like, okay, just
Okay.
kidding, we're done. It'll be short. I don't want to scare people off, but I think it's yeah, no,
That
I've
ship has
literally
sailed. I'm sorry. I'm sorry to tell you, but that ship has sailed.
I think people that are here today are the ones that care about that sort of stuff. The other ones are just not showing up.
I
I'm
understand, you
kidding.
know. Completely understandable. I don't blame them.
I mean,
Yeah.
I'm curious, even if I understand like 1 out of 10 things, I'm still curious anyway, so.
Yeah. Well, I guess like there's a couple different places we could go from here. Because I'll be honest with you, I didn't take my ADD medication today, so I'm all over the place.
It's all right.
Yeah, we can talk about some of the differences with K1 and K2. We can actually like keep going through some of this, or if we want to just take a really quick look just to see how deep that stuff is. Let me see if I can bring up my IntelliJ.
Okay, you work on bringing that up. One thing I would ask is, because we are only on slide 2, do you want to go quickly through the other ones and pointing out the things you learned along the way? Like why you have gotten through, I guess, 4 different representations? I think for me personally, it would be interesting to know the journey. Even like it's not even about the content. It's just like how the fuck did you get to where you are now? Is interesting to me.
Yeah, no, that I would love to talk about that. That's exactly what I'd love to touch on. So, yeah, I would say at this point, this might have been right after. Oh yeah, yeah. I would say a lot of these compiler or some of these renderings are based on talks that I've done, where it's kind of fun because I end up doing various talks on portions of the compiler based on problems that I'm doing. That's the cool thing about the compiler. It actually covers a ton of problems, and it's not just compiler plugins. Like, for example, even like if you think about leak code, I'm definitely against doing leak code for tech interviews in general. But that aside, a lot of the leak code questions do cover algorithms and operations that are based on the compiler itself. So that's just kind of a fun tidbit. So yeah, the first 2 that we were looking at, I think one was from like the shape of Kotlin. The next one I think was related to research around error meta. And this is when we start kind of going into the compose stuff. So I've been kind of switching between Android SDK work and compiler stuff. And Compose came out a few years ago. It's been crazy popular ever since. And I did a talk with Yossi Wolf on Hitchhiker's Guide to Compose compiler plugins and more. So there's like a lot of stuff around that. And it's kind of fun because I actually didn't use Compose previously. Like I'm like, well, I don't know how it works, but I can like lift up the hood and see what's there. And
you're the person that has never used Compose but still wants to know how it works at the compiler level, and you're like,
that's me.
Damn.
I have to know how it works in order for me to use it.
I don't care how I can make a button. I don't care if I can make a button. I just want to know how they actually build the tree to make the button.
Yeah, so. Exactly. You know, they got some, like the Compose compiler stuff is so crazy. I know they say, oh yeah, it's a lot of magic, but it's like my pet peeve. I hate hearing that anything works like magic. I'm like, it's not. It's there's a lot of steps in between.
There's some very
So
smart
yeah,
people that have put a lot of very smart work into making it work.
yeah. And actually, this is kind of the cool thing. You know, since Kotlin and Android kind of became like a marriage of some sort, the two platforms have really started like kind of exposing some problems between the two, but also like finding solutions to make it stronger. And Compose was one of the reasons why I think like K2 had been pushed to like improve some of these things. And so when Compose compiler plugins were being developed, there was some work being done side by side to be able to accomplish some of the goals that they have. So I don't know how many folks are familiar with Compose. I'm sure there's quite a few Android folks. Compose, of course, is multi-platform, but the idea is that it's a declarative style UI that can be used. And it's kind of funny because after looking into this from the compiler level, like I stand by this. I feel like Compose is trying to be like Tornado FX because that's why I love Tornado FX. It's also declarative style. And like it even
No
had this.
offense, you might be one of the 5 people in the world that love tornado effects. I really
I,
don't know many people that liked it. You are the second person that I know that actually ever used it.
I need to meet the other person.
They work at JetBrains.
No way. I'll have to find out who. Yeah, no, I stand by this. It's funny because I actually asked the Compose compiler team, like, have you guys heard of like tornado effects? And they were like, no. And I'm like, are you for real? Like, I just blew my mind. But yeah, I think there are like a lot of like parallel ideas around this stuff. You know, there's a lot of great benefits that come from declarative style programming. And one of the intense thing, like there's a lot of intense things that Compose in particular does, intercepting the phases of the Kotlin compiler. So when you write plugins, you can actually intercept pretty much any phase. Oh yeah, hydrate check. Oh, this drink is so sugary. All right.
It's gonna help. Keep up the energy, you know?
Yes. Yeah. Right. So the Compose plugin does actually a lot of things. So if we talk about everything we've talked about, but now we have Compose kind of like intervening in the picture, you see like the little Compose symbols. So we start with generating tokens. And then in syntax analysis, there's actually like a little bit of intervention here because Compose has special Kotlin types, you know, like there's like the @composable. So instead of recognizing that as a function, that is now specifically a composable type. So they have to include these new definitions in the PSI of like, what do we consider a Kotlin type? So you can create new types at this level. And yeah, so we go through analysis, and I would say the heaviest bits of work for the Compose compiler plugin is both at resolution and especially in the backend. So there's maybe some extra information that enhances the PSI elements with the descriptors. And the same is true for resolution. You know, there's just additional rules to make sure that things compile correctly. There might be some, yeah, so I would say it's pretty simplistic. If we, hopefully the next slide is the back ends. Let's see. Good day. Good day. Right, we send that unoptimized IR, and this is where it gets crazy, because remember how I was talking about normally the idea of starting with your unoptimized IR is that you want to simplify your IR and the operations so that the bytecode can compute a little bit easier and a little bit faster. There's a lot more that goes on here. So for example, Compose compiler plugin will actually blow up the IR. So instead of making it smaller, it's so much bigger. Like it's almost mind-blowing.
Is that because it injects a lot of logic or because
Yeah.
okay.
Yes, and just to be clear, like this is a use case I've never seen personally, to inject additional logic. Like normally when we talk about compiler plugins, like maybe we'll like alter one small thing, like Sam with receiver in Kotlin.
Mm-hmm.
It's like very, very short classes where we kind of like alter like how that's interpreted, mostly at the resolution level. But Compose made an interesting decision where they wanted to have runtime, like during runtime, like a special memory like stack of its own. And this memory stack, mostly like it's between, I think, like snapshots and the composer. Um, they created like their own like logic and trees like at this stage. So that's why all that stuff is blown up, because they create all these like groups, which helps to like, this is like that magic where Compose automatically refreshes. Sorry, I'm like blanking on the term. Like, you know, instead of doing the live data binding, it just knows to refresh, to recompose. And so yeah, that's where that magic is happening, because there's all this text that's blown up, and they actually like insert additional parameters. They'll have like a bit mask and a composer on top, which keeps track of which composable types have been dirtied in state. So it keeps track of all that state. So this is kind of like where a lot of like this idea around snapshots come from.
Mm-hmm.
So yeah, really cool stuff. And I believe, you know, I'm blanking on what happened in the CPU related side for the code gen phase, but I'm sure there's like additional logic that was included that I'm like, oh, well, there's some stuff here, but not as important. It's not as heavy. So some of the heaviest work is done at the back end, specifically for IR lowering transformations. Yeah. So yeah, it's kind of funny when we did this talk with this Hitchhiker's Guide to Snapshot. Yossi and I ended up getting interviewed at Google, and he ended up at Google. And we did this talk at least a few times last year or the year prior. And there was one time he was sick and he couldn't come to London, so I kind of had to do the talk, and I was like, oh gosh, I need to like restructure it so it sounds natural for me. And Chet Haas like sent Yossi an email. He's like, hey Yossi, welcome to Google. By the way, I saw Amanda's talk in London, and you know, she got like there's it's not a big deal. She just had this like one little part wrong. It's like novel about how
No pressure at all.
Oops.
Yeah, it was like simultaneously a nightmare and a dream at the same time. Yeah, it was I think it was specifically on exactly how Android would know to refresh the views. But then we ended up taking that part. I would have corrected it, but we took it out eventually because we just kept trimming it down more and more. But yeah, that's just kind of, so this is like the Google-fied version of all the renderings that I've had thus far.
You can tell from the colors and the shapes and the fonts that this is the, you know, official looking.
It's the official looking Google. Yeah, it's fun that there's like a Google version of this. I hope they use this somewhere.
I don't know, maybe it's on DAX somewhere, Ivan would know.
Oops.
Oh my gosh, if you find it, that'd be so cool.
I don't know if they have it anywhere on DAC, but it would be cool.
If only we're not part of the cool kid club. Well, I guess you are, Seb. So anyway,
I don't know. I'm working on swing stuff, so you tell me.
Oh Lord, yeah. So yeah, this one came right after. Yeah, we did the Compose compiler talk for a while, and what I realized after looking at all the plugins I've been looking into, not just Arameta and Compose, I realized like, oh, there's like a pattern to this stuff, you know, like you can actually learn a lot about the compiler with reverse engineering compiler plugins. Like honestly, that's the second way. So two ways, learning if you want to get into compiler work, I think starting with PSI breakdown is great. Actually, at some point, Sebastiano, I think you mentioned briefly, and we can definitely try to share this. It's on IntelliJ. There's this excellent library called PsiViewer. It's a plugin for the IntelliJ IDE, and it's so cool because it just kind of sits in the side. I don't know if
Is it here?
Oh, that should be. It should be. But you
Ah.
know what I'll do? I'll send another link just in case. But yeah, PsiViewer is sick. Like, if you don't have it on your IntelliJ idea, like you got to put it on because it's great. Yeah, it's really cool. I don't know if they have a screenshot in here.
Probably not, but I can. Maybe there is a blog post. Ha!
Oh yeah.
Wow.
Oh wow. So old looking.
Yeah.
I had no idea there was a.
This
Look at
is
that.
3 look and feels ago, maybe 4.
Oh my Lord. But yeah, I mean, give or take, I'm just shocked with is that Windows? Like,
that is
cool.
Windows 2000 probably.
Old.
Windows I mean, old. It's 2009, so that would be, I guess, Vista maybe, but with the IntelliJ look and feel. The very, very old IntelliJ look and feel. This is the first one, I think.
No way. This is like back in the day. Yeah. But yeah, that PSI structure that you see, like that still exists like in the modern version, and it would like just sit on the right side of your screen. And it's kind of cool because like when you are working with your code, like you can open up this extra window and you can literally highlight the code and it will tell you what PSI elements they are. So these are the tokens with the overlay. So yeah, if you're on your IntelliJ idea, you can go to, I think, project or structure, and you go to your plugins and download it. And oh, I actually have it on mine.
I was gonna open IntelliJ, but then Toolbox was like, "Hey, I need to update." I'm like, fine."
That's all right.
So I gotta open the IDE in a second as soon as it's done. I don't need to. I could just open it.
Yeah, I think this would be a cool one to show everyone because I think if everyone walks away watching this with their PsiViewer, I don't know. I think it's just so cool. It's, let's see. Is this presenter mode?
No, it's just very big text. It's stream friendly.
Error.
Oh yeah. Oh, they got some new updates here. It looks kind of nice. Modern.
Ish. There's the dividers are weird, but I'll file a bug maybe if I remember. But I think it's useful to show it with Markdown because it's much easier to understand what's going on.
Yeah.
So for example,
so you can use it for every file, basically.
Yeah, any file that has highlighting support in IntelliJ builds a PSI tree. Kotlin is one of them, but obviously Markdown as well.
Fair enough. So, because of the tokens thing that we were talking.
But you can see, for example, the root is a Markdown file, and then you have this. I guess this is like the header 1, and then there's a PSI element that is the actual header notation, and then there's the content of the header. And then inside of that, you have, so there's, you can see starts at the space because it's everything. But then there's also only the actual text token. So without counting the separator here. So that gives you an idea. Maybe we can open a simple Kotlin file to see how it goes.
Yeah, that'll work. And then it's cool because when you like highlight the text, like it will automatically highlight the tree for you too.
Yeah. So you can see, for example, we have the file. I think here it says dummy.kt because it creates a copy of the file in memory. And when you create an in-memory file copy, it's called dummy.kt because it's not a real file. But you have the package directive, you have the PSI element for the keyword, and then you have the dot qualified expression, which I'll leave you, Amanda, to explain what it is.
Dot qualified expression. Yeah, so they, yeah, I think what it literally is just any expression where it's like, I don't know, like object.run or even be imports too. So I guess in this case, it's the it's.code with the Italians. So it's counting all that as a dot qualified expression.
So essentially every one of them is like a pair of two elements separated by the dot. And then it's composing them to make longer runs. I see. Let's see imports.
I think I saw it, but
import list, import directive, and then here,
Oh, that's cool. You can even see the individual ones, like the plugins, dynamic plugin listener, plugins.idea plugin descriptor. And I know we were talking about a little bit earlier, like IDE plugins versus compiler plugins. I'm not sure what class we're looking at, but have you been playing with the IDE plugins?
Yeah, this is an IDE plugin.
Ooh, that's sick.
Because we have custom progress bars in the IDE now that have our angry pizza and an Italian flag.
Oh my
Priorities.
Gosh. As part of like, just tag it with this talk. Like, that's cool. I'd love to look into that because writing IDE plugins, I feel like, is harder in a way, just because it's something that doesn't have as much documentation.
There is some now these days, but also
have changed.
So wait a second, I'm gonna show you. If you go to plugins.jprins.com/docs/IntelliJ, so there's quite a lot of documentation these days, and there's the stuff about PSI is here as well, which is fairly useful. There was something else. There is somewhere. I don't remember where it is, but there is like a endpoint. Oh yeah, there it is, the Explorer thingy.
They have like an API now, right?
So this indexes all the open source IntelliJ plugins that there are and all the extension points and like exposed items that they have. So if you're saying, I don't know, I want to say, I'm looking for how to do something in GitHub, maybe a better example. Let's say theme, I don't know. So this tells me that these are the extension points that exist in the platform. So theme metadata provider and theme provider, and I can select one and I see all the open source implementations that there are. And if I click one, then I can see details about the plugin. It tells you the repository, it tells you which extensions it has, which is fairly cool because then you can just open the page. Obviously, it looks like it's broken now, but it's going to be fine at some point.
Happens.
Yeah.
You know what? I kind of feel like that's been happening a lot with GitHub. I don't know.
Yeah, they might have changed something somewhere. I'm not sure.
Yeah. Yeah, because it wasn't like this for a while, and then I noticed, I don't know.
I think I need to sign in before I can search. I don't know. GitHub.
So annoying. Yeah. Thanks, Microsoft.
Thank you. Anyway.
Yeah, I swear. Yeah, anyway. Yeah, but yeah, thanks so much for showing the PsiViewer. For viewers looking into this, you can literally download this as a plugin in your IntelliJ IDE.
You don't need to download it anymore. It's included in the IDE, by the way. The only thing you need to do is, I think it's
enable the view.
It's here, but you need to enable the internal mode, which you can do from edit custom properties, and you write this idea.is.internal equals true, and that adds a lot of internal actions that you really do not want to mess around with. Because this will break shit.
This is
I'm gonna go when I get off this. I'm gonna play with all of this.
But if you are,
look at how many menus?
Oh yeah,
that's a lot of menus.
today.
There's more.
at that.
If you're developing plugins, this is very useful because you can like simulate freezes. In the UI, you can say, oh, I don't know, I wanna.
Oh my
Let me
God.
see, where was it? I never look at the menus. It's way too much stuff.
Can you do show splash? Can you do show splash?
But
Yeah.
you can also search for the internal actions. So you can see, for example, this is what we were using while developing the plugin
This is just
to see
blowing.
how the progress bar looks.
So many. So
See,
many
this is
of
like
them.
we're in the secret side of IntelliJ now.
But there's literally
Android
nothing
debug
here
menu.
that is useful if you're not developing plugin.
Oh, there
Oh,
was
yeah.
a show splash, Sebastiano. There was that. I think it's useful. Show splash. What do you do?
It
What
shows
does
it on the other screen, so
Okay, but it shows it.
it shows,
Okay.
yeah, just on the wrong screen.
Don't worry, don't worry. Anyway, as long as I can trigger it, like just for the sake of having the
Yes.
splash.
Yeah.
Look at
Oh,
that progress
man,
bar,
so
Sebastian. It makes me so proud.
It's freaking out so much, and it's amazing because it's reporting like 20 errors, so it's like reporting all of them. It's like, "Ugh."
It's just
But it's
great.
also very. It's
appropriate.
Showing, yeah, it's appropriate. Right? It's
I'm
showing
also
the
I'm
right
also using
energy.
it in my work IDE on my work computer, and I realized that there are a couple of bugs, and I want to fix them at some point, but I don't know when I'm gonna have time. But I will fix
Yeah.
them at some point, so we can have a version 2. I don't know.
Ooh.
That's real.
But
Oh, sorry. Yeah, that's actually, I'm glad you brought that up, because I feel like this is another good aspect to think about with the Kotlin compiler and IDE plugins. When you're working, for example, with like just really either or compiler or IDE plugins, sometimes you create something where it doesn't like really like mesh well with the existing behavior. So what sometimes that will turn into is the IDE telling you, oh yeah, this doesn't work, this doesn't compile, because it like just doesn't know. So that's kind of a fun tidbit. Like I think there was a time in Kotlin where or using like Android Studio, I think Compose was super new, and there was just like a couple things where it's like we have no idea how to interpret this, but it still ran. It just the IDE didn't know. So that's kind of like it's a fun thing to think about.
I'm just
Yeah, you can even do
mesmerized at looking that there's like the block structure that tells you, oh yeah, you know this line. I was like, if this were to go on a new line, then I would use the continuation without first indent style, and that's like, yeah, sure. It's just
Wow.
silly
They
fun.
even got it all block structure now. This is like they really made this really nice. Like you can see the original PSI tree, and then they have this really nice way of just like having these blocks for you. Wow. Looks so nice. But yeah, I would say if you want to get into compiler stuff, I feel like this is like the first and most important bit. Just get to know the PSI, because everything else is going to follow. And even talking about like, you know, when we get to like the IR level, I think I will show some sample screenshots. It might be like a little recycled, but that's okay. Just coming from, let's see. Yeah, I think we could do that. Because yeah, I do have like, I think I have a couple sample. Yeah, let's talk about that too, because like I think we're about to anyway.
Yeah, sure.
Yeah, so there's K1 and K2. Would you mind going back to the last one?
This one?
And then, yeah, K1 front end. So we've been talking about all these renderings of the Kotlin compiler, and I decided, well, this stuff has been sitting in my head for like 3 years. I better start writing it all out. And it's been pretty slow. I mean, there's been like a lot of job changes and whatever. But I started writing the article for resolution, and I sent it over to Dmitry Novozilov for feedback, and he tore it up, understandably. And then I realized all this time, oh no, I've been studying the K1 compiler. Everything we've talked about so far is K1. So there are some notes I'd love to share about why, like I know we kind of mentioned some of the motivations briefly. Some of it being that the IntelliJ IDE was slow to compile. On top of that, there was a lot of significant changes being made with like compose stuff, but there was like a couple other things too. Some of the main problems of performance for the front ends like 1.0 version or K1, it was mostly related to bad code locality and memory locality, because we talked about sending over PSI, binding context, and descriptors to the backends. And when we do that with K1, we start with this like PSI to IR, which transforms all this into IR. And some of the issues around this was that it kind of killed like a number of JIT optimizations because the descriptors were like lazy, and the compiler always had to make these like jumps with different parts of the code. And the binding context is basically just one big hash map. So if you think about your LeetCode code, your LeetCode code studies, like, this is like hash maps are mostly fast, except for, when you start having to make so many jumps. So this is kind of what was happening with some of that. So going to the next slide, we're going to talk about what K2 does instead. So we actually add an extra step to what is going on. So we generate like the binding context and the PSI, the PSI and the descriptors. In K2, there is additional analysis and resolution being done so that it actually creates an additional data transformation. So now we have a new data transformation to work with called FIR, which is called otherwise known as front ends intermediate representation. And there are some benefits to a lot of this stuff. The result is that everything became so much faster because they decided to desugar. When we have the IR, like what they used to do is like do desugaring, which was like the 3 to the power of 2, change it to 3 times 3. So they did all that in the backends, but now we have the capability to do some of that desugaring previously. And the other nice thing is that the FIR structure is smaller to work with. It's, I guess, like a bit more local. I would say I feel like FIR is now stable. I know, like for 3 years it's been kind of lagging. It was ready. It's a thing now, so that's it is a thing now.
They did talk about it at Kotlin Conf, didn't they?
They did. I did watch Roman's talk, but later on, because like that morning I was also getting ready for my own talk. So yeah, they did talk about it. I guess it's now stable. Someone can correct me for that later.
That's how we roll.
Yeah.
Eventual consistency with the world.
Maya said as soon as Amanda wrote it down, it changed. That's kind of what happened, though. Because when I started looking for the compiler stuff and like Arameta, we're like, oh, when is this K2 stuff going to come out? Because for a long time, I was working with the PSIs like purely, and then when I came back to it recently, I'm like, oh, what the hell's all this FIR stuff? Like, why? Now I have to learn a whole other thing on top. So let's talk about a little more about FIR. So this actually this replaces like the first front end version. And so we've talked about how this kind of increases compiler performance. And these are not my words, but it's a cleaner architecture to replace like the piece of crap FE10. It's not mine, maybe I should. But yeah, so a lot of these structures were rid of. And of course, an FIR is also a tree, which is mutable. And it's built from the results of the parser in its raw form. So it actually looks pretty close to IR. It's a very similar look, honestly. And after the raw FIR is built, then it's passed to a number of processors, which resolves the code. and it'll represent different stages of the compiler pipeline, and then it just resolves everything in bulk. So this is where we start resolving for imports, super types, sealed class inheritors, types, status contracts, body resolve stuff.
So
Yeah,
can I ask you a question? So K2 is essentially a rewrite of the compiler front end, right?
yeah.
But am I mistaken that the backend was also rewritten at some point a few years back?
It was
So
rewritten.
what we are essentially going to be using or using already today is not the same compiler that we were using at all a few years back.
Pretty much. Oh gosh, some of my memory gets a little fuzzy around some of the changes around the backend, because the backend changes I don't think was as big of a deal, because I think it was just already done a little while back. I kind of wish I included Savannah had this amazing talk talking about the basics of the compiler. So I think what I'm going to do is, after this session, I'm going to add other people's talks that I found instrumental to compiler studying, and her talk is one of those. And the main, I can't remember what exactly the main changes were with the backend compiler, but what I can tell you as it exists right now, I'm so sad I didn't include like some of the options for compiler, the backend compiler, but you have stuff like, so you basically have 4 options right now. And this is kind of interesting when you send everything to the backend and it becomes IR, you start with kind of, it doesn't matter which one you choose. There's 4. You can have, of course, the JVM, which will turn the IR into bytecode. You also have native. Let's see, what else?
JavaScript?
I'm blanking. JavaScript, and then WASM. Still don't know what that is. It's experimental right now.
The
But
WebAssembly stuff.
Yeah,
Well,
assembly
it
stuff.
should be, yeah, the WebAssembly stuff should output still like a binary file that can be run in the browser. Because now
Interesting.
the browser is getting closer and closer to a full OS in and by itself.
Oh man, I've been far away from web development for a long time. I think it's going to be interesting to see more content on that in the near future.
So according to the RAM that my Chrome is using, Sebastiano, we reached already that point of being because I mean, again, the thing is just sucking how many gigabytes, like a gazillion. Just it's more than IntelliJ. Just telling you that.
Yeah.
Right at the moment is more.
Wow.
It's like 5 gigabytes for Chrome, 3.6 for IntelliJ. Yep.
Yeah, and people keep complaining that the IDE uses too much RAM.
No,
I don't think so.
Yeah. Also, I don't know if this is still true, but I think Chrome is running off Electron, which is a bit heavy.
Well, kind of. The relationship is more like Electron is the web part of Chrome taken out of Chrome, which also means it's losing the security measures that Chrome puts around the web rendering.
Who needs that, Sebastian?
Nobody.
Who needs that? Only the brave.
I'm not saying it's intrinsically insecure, but I'm also not saying that. As in, you need to know what you're doing a lot more than if you were just running. So you can run literally the same web page in the browser in Chrome, and it's going to be fine, and running it in Electron, and it's going to be insecure because there is no sandbox around the page, whereas the browser does that as well.
Wow.
Fun stuff.
So
I love web apps.
We should I guess we should try using Safari a little more or something.
That's not going to change anything. Electron is still going to be based on the same thing and having the same problems.
Yeah.
So if you use Chrome, it's fine. Just use web apps in the browser and you're okay. Don't use web apps via Electron pretending to be native apps. That's my taking.
When they ask you, do you want to download the app? You say no, not today.
Yes, yeah. I mean, this page is as the tweet or the tweet that I see a lot recently is like the screenshot of this page is much better in the app, and I'm like, and whose fault is that?
Oh
Fair
Lord.
enough. I like
Yeah.
it.
Oh yeah. Well, I think that was a lot of good information about WASM. But yeah, as far as I know, it's still experimental. Actually, yeah, let's keep this because this is like the most recent. Because recently, I think I got some really great feedback from folks. They're like, Amanda, why is this not linear? It'd be a lot easier. I'm like, yeah, you're right. It'd be a lot easier. So yeah, once you hit the back end, no matter what backend compiler you run with, JVM, JS native, or WASM, they all start the same. They both will generate the IR and then optimize it. So that's the IR and the lowered IR portion. And then whatever mode you end up going with, that's when the target code is generated. And I believe it's optimized, but we'll just talk about that a little bit less because, it's a whole bunch of rounds of compiling and lowering. But yeah, I would say this version, it doesn't really like cover like, oh, what phases are what, the lexer, the parser, resolution, the lowering, and then CPU optimizations. But this represents all the data transformations of K2 and the backends that we've been talking about the whole time. All of this stuff is a little bit tiny. But I'm sure, like, I think, like, in some of my Kotlin Conf talk, we had some of the slides which kind of showed examples of that. I might have, like, some rendering of sample output, maybe, that I could look into. But yeah, I think that kind of, believe it or not, I think we've made it through just about, we did it.
The whole deck.
We did,
We
yeah.
survived the run through of the entire Kotlin compiler, including K1 versus K2, which is not bad for
That's not bad.
an hour and a half.
Yeah, all things considered, there's just, I can't tell you how many hours I put in to be able to create that simple of an explanation.
So the simple things
I
are
bet.
always the most complicated, right?
Yeah, exactly. Yeah. And of course, some of this is covered in the compiler articles. And like I said, I'm going to add some additional talks from others that I think would be instrumental for others to learn about this. And I don't know. I guess I'm not sure how much time we have left, but if
About 10 minutes.
Okay, perfect. I can share the screen.
Sure.
And let's see, share screen. We can kind of quickly cover, oh, God. I have to open system preferences. I thought there was the whole thing for that.
Right.
Oh my goodness. Hold on just a sec. Okay, good day. No, but I would have to quit and reopen.
I mean, if you want to do it.
Try ignore it.
No, you cannot ignore it. If you want to screen share, you need to restart. Restart Skype, it's fine. We'll talk over it.
Okay. Okay, I guess
Go
you
for
could
it.
just come back. Okay,
Go for
I'll do
it. Go for it. Go for it. So, Ivan.
Yes.
When are you starting to write your first compiler plugin?
So.
Yes.
Okay. I'm so.
We did. It was faster
Is
than I.
the sound gone? Is it? Can you hear us? They can't hear us, Sebastian.
The things are moving in the microphone levels.
Hear me?
I can hear you, but I cannot see you.
Yeah.
Interesting. Okay, I'm gonna go back and go back out.
It's fine. It's fine. What?
They said it's fine.
Oh, it's fine now.
Start the
Yeah.
share.
Okay. Yeah, I'll start the screen share.
Okay.
Sound is coming. Okay.
Perfect.
Skype.
Sharing? Oh yeah. Okay. Oh, good for me. I had the Kotlin compiler up too, so we can briefly look at that. But I actually
don't see the screen share, by the way. I don't know if it's just me or.
No, I don't see it either.
Traced.
Amanda's screen is frozen. Yes, I also see her frozen.
Okay.
Let it go, let it go.
Even
Jesus,
please.
why?
You
Yeah,
have a
why I'm doing
kid. You
this?
have a small kid.
No,
That's your excuse. But
why?
still.
Why I'm doing this? Why I'm doing this? Now it's stuck in my mind.
Now
Is it
you've ruined it for everyone.
No, Amanda. Unfortunately, I see you frozen still.
We
No
have
way.
dared flying too close to the sun.
Come on. I mean,
Yeah.
we can try another start. Let's try another start, shall we?
Or just close the call and reopen it. That might also work.
Close the column and reopen it.
Yep.
Okay. Close the. What do you mean by close the column?
Just hang up and rejoin.
Oh, okay, yeah.
So Ivan, we're talking about your first compiler plugin.
Yes. So I'm telling this at some point. So my desk faces my my door, right? So and there is a glass. So if somebody approaches the door, I can't see through, but I see like the shadow, right? The silhouette is one of those blurred glasses. And at some point, I saw that Francesca was behind the door. I was like, I have a baby. Maybe something is happening, right? And then she got close to the door and then she left. So I quickly sent her a message. Everything okay? Everything okay? And she goes like, yeah, there was an unfamiliar and uncanny and concerning silence coming from your whole studio, and I wanted to check if you were still alive.
So, as in, you weren't swearing enough.
I was like so into the I can't understand shit of this stuff. I mean, I'm dumb. This is like, this is imposter syndrome. There was so much silence that my wife worried. Okay, so this is just to give you an idea of the amount of information that I was trying to process during this episode. So thank you, Amanda. That was very, very, very appreciated because this is very interesting and I know very little. And I know so little that my wife worried that I was dead. That's it. Okay.
Maybe
That's
you had
it.
a stroke or something. Who knows?
Yeah, he had a stroke, right? I mean, he usually is yelling and laughing and ha ha ha, and now there is silence. He's dead. That's it. That was the assumption.
Am I sharing the screen?
Yes,
if not,
we can see it now.
We can see it now. Yes, amazing. Okay, super quick. Yes. Here's an example of a complete code transformation. We start with fun 2. We talked about in the lecture phase, like everything literally gets split up into fun keyword. You have KT token identifier, then you have these other ones. But yeah, they all get matched up. And then here's a screenshot from the PsiViewer. This is also like what it looks like in mine. And then it's kind of neat because you can see the property and like a lot of that kind of like that descriptor information we were talking about. So this has a lot of that information already. Oh, I only have one screen. Well, so I'll share the screen again in a little bit. So yeah, once that happens, so we kind of have like this like the PSI AST tree, and then here's what the raw FIR looks like. So it looks very similar to the actual code, but I guess I'm not really sure what the question marks are about because, like I said, this is new for me too. But yeah, it kind of tells you explicitly if like the typing is implicit because before I think we didn't say explicitly that it's an int, so it's like, oh, okay, this is implicit. And now we're recognizing this.
Wow. So if the type was inferred, you mean?
Yeah. So in this case, the type was inferred. So during the resolution phase, it's going to, this is one of the questions that it answers is what is the type and is it implicit? So yeah, there's like a lot of stuff around that. And then I think the ending result of the optimized FIR looks a little too simplistic. Didn't really understand why. But I think that's what the testing spat back. I know there's not a lot of room left for this, but in the compiler notes, like somewhere in that repo, there's like notes on what are some ideal debugging points for testing, because the best way to explore all this is through testing specifically. and we'll cover that maybe
so
in
just
5 minutes.
putting in some code and seeing what gets spat out.
Yeah, yeah,
Fair enough.
and with the testing in particular, and then of course here's the FIR, which kind of blows it back up, and it has more explicit stuff.
Mm-hmm.
And now I'm gonna stop sharing the screen and do it again. One more time. Let's see if it's gonna take the whole time, because that would be nice. Can you see the whole screen this time?
Yes.
I can. Yeah.
Okay, here is the abyss. That is the Kotlin compiler. We're gonna try and close all this up.
They're asking what note-taking app you're using, by the way.
Oh, this is Evernote. I love it. I've been using it forever. I'm a big fan. The free version, like I've been using the free one. I really should pay for it at this point. I was just seeing how far I could go with it.
They were bought by an Italian agency last year, I think.
Yeah.
Wow.
Yes.
Yeah.
That
Which
then fired everybody, but that's
yeah. That was like unexpected.
Yeah.
Wow. Yeah. Yeah, I would say it's one of my favorite apps for taking notes, and I like that you can like have it on your phone or on different computers. So that's pretty nice. But yeah, you can see how the Kotlin compiler is organized with no rhyme or reason.
I mean, it's in alphabetical order. That's all you need to care.
But that's something. We'll take that. But see, you have like the order, and it's like, why they put everything everywhere? Just, you know, how are you supposed to actually go through all this? Like, it just keeps going. Like, I guess they have their own, like, now that we talked about all this stuff, at least some of the stuff means something to us, even if it's not organized in a way that maybe makes sense to us. Oh, this is amazing. Would totally recommend if you have the Kotlin compiler set up. These are all the like mini plugins that you can go through. In my actual talk, I think we talked about SAM with receiver. I love this one because I love the small examples. So yeah, like I said, all plugins, especially compiler plugins, they're going to have a similar setup. You know, you have your command line processor, you put in your CLI options, so you gotta set all that up, and then you register extension plugins, which tells you which parts of the phases of the Kotlin compiler you're intercepting. So yeah, this one is super small. I like working with this one, and you can see here they have the K1 and K2. So we'll just go straight to the K2, and then here it has the FIR session, which is it's a pain.
It's a thing, yeah.
It's a pain to get into the way that they set all this up. But you can see here that we create a brand new functional type. And of course, like running the tests here, so won't run on this computer. Like I said, you need Java 6 installed in order to work with it. But yeah, like running the tests and then debugging that is hands down the best way to actually try and navigate the Kotlin compiler. And other than that, I'm going to point out this one place is probably a really good place to start if you want to know, like, what's the shortest amount of code that I can look into that represents all of this. So this is the FIR Kotlin to JVM compiler. And I'm pretty sure they have like compile modules, and then it's like, you know, execute the front end, execute the back ends.
I love how this is really like a small example, and it's still like, what, 500 lines?
This is the shortest one. It's as short as it's gonna get. Yeah, this is as simple as it will get. I've spent countless hours trying to find something simpler. Dimitri was, there's actually other modes of like compiler compilations as well. Like I think I was looking into like the analysis session. That's like a whole different thing altogether, which is kind of fun to look into. Dimitri's words were, I wouldn't talk about that because I don't talk about it with my students until like 20 classes in. And I'm like, okay. Fair enough.
Damn.
Yeah, no, this is like it's really heavy stuff.
No. Why do you say that?
It's all poking and prodding.
This is so digestible for me. So
I can totally see the abyss. I can see it.
Yep.
It's staring right at me now.
Yeah, it's actually Oh man, that's
Oh,
brutal.
yeah.
This
So
is
that's like
brutal. But
this is the abyss.
I can't even understand the UI, right? So but I'm so lost, right? So I was like, okay, this looks like IntelliJ, but the panel on the right, oh yeah, that's the plugin that they were talking about. There's still
Yeah.
okay. Now she clicks, and now something moves on the other side. I was like,
Oh
okay,
yeah. See,
okay,
that's the cool
okay,
part.
and now she, I was like, I'm I'm struggling. I'm struggling here.
Yeah. But yeah, this is it. We finally made it here. I didn't think I was gonna show this today because it's like once you open this up, you're like, okay, time to close the screen. We're done for the day. Yeah,
But the
and
beauty of this that this is gonna be a VOD, so people can watch it and rewatch it, slow it down and
Zoom in,
search and open
enhance.
things, enhance. Well, or they can play it like 2x, and we will do like a speed run through the compiler, and
I
it's
mean,
gonna
they
look
can
like one.
do it, but I wouldn't. I wouldn't.
I wouldn't.
It was very information
Really?
dense. It's easy to get distracted 1 second and just miss everything because it's two times faster.
literally,
Yeah, that's
literally. Yeah.
But this is intense. I love it. I mean, this is a lot. This is again one other episode where we are supposed to be doing the same job, right? So if you go to LinkedIn, kinda, right? And
Yeah.
then I have never even touched slightly something like this, and it's like it's the same industry, right? And then this was something that we were discussing this morning. I mean, you have people like you doing compiler plugins, and then I'm spending an afternoon trying to center a div, right, on a on a website. It's like, yeah, the same job, straight
It's
same
the
job.
We all get paid the same,
It's
you
the
know?
same job. I mean,
Yeah.
that
See, that's
box
the
is
fun
not
part.
gonna lie itself. So
I think that's the fun
Oh.
part. Oh, here's the funny part too. Like other people before me have definitely tried documenting the compiler. We all have slightly different interpretations. As a lot of these notes, like they're sitting in the link tree for the crash course to the Kotlin compiler. I am going to point out, like just for the sake of, since we're recording this, there are some key debugging points that you can look for that I think can be helpful for that stuff. And then I think I also included notes on how to, like, which test might be useful for you to run. So I think all that can be pretty helpful. I would say, let's see, if we go here, and then I'll show the same in the last 5 minutes in the compose compiler. You can see here we have the test setup. So whenever, it's interesting because when you debug the compiler using the tests have their own compiler setup. It's like sort of a compiler, like usually you need a little bit less setup if, say, you only need to work with FIR, for example. So yeah, like usually there is some kind of setup needed to kind of like work with some of this stuff. So if we look at, let's see, this is one that I was actually running just for funsies, and I did get this one running, so hooray. There are, like, if anyone wants to play with the Android X one, there are these, like, yeah, this is it. How did I get this other view? I'm gonna get that out of here. Yeah, there's this code. I'll put it in the chat, but these are the instructions to be able to work with Compose. There are separate instructions for the Kotlin compiler and the Compose compiler. I'll just drop that in there for anyone that's curious, because this is another way to get into it. It doesn't actually hold the Kotlin compiler in this code. This is actually just Android X. But yeah, it's possible to like run testing on this too. So I think it's gonna work here. I don't know if I have debugging points set up. I might. Maybe I'll just. Oh. Also, my computer is very angry. Understandably, I have the compiler open. I got Android X going. I don't know, like if it's gonna run
I
real
think you
nice
need
for
2
us.
buckets of RAM for that.
For real.
Skype.
But yeah, so you can see here, like there's this control flow, and I actually love the way that they do this because I think you can learn a lot about the compiler this way too. Literally just running through the tests and making your own input and forcing it to fail. Because you'll see here, oh, look, Leland Richardson. I gotta say, this is one of the nicer setups that I've seen for setting up the testing. So you can see that they kind of have like their own little test setup compiled to IR, for example. So if we go there, then create compiler facade. Ooh wee, we're deep in it now. Yeah, so you can see here they have like the compiler configuration. I know we talked about that a little bit. Then there's like the register extension stuff. I'm like, oh yeah, here we go. I have some notes because it gets a little, it's like, oh, what the hell are we looking at, So
it feels like
anytime
you need an old-timey explorer map that says "Here be dragons" at some point.
you literally do. That's why I created that map, because you need a map for all this stuff. Like you need
Man.
notes to be like, because it's impossible to remember what all this stuff is. It's so. We have the compose plugin. If you want to, oh yeah, sure.
It's fine. It's not gonna be mining block like
get out of
bitcoins
here.
or
Anyway.
something.
Yeah, but yeah. So you start with the compiler plugin. Oh, it actually ran. Look at that. And I would say, like I said, this is hands down the best way to look into this, because you can actually look in. Oh, it doesn't look great from here. Here we go. Yeah, check this out. So if we went to the before and after, let's see, we're going to go back to the original one. This is the code that we had initially. Yeah, there we go. Let's see. So there's fun example, which is a composable. It has the accent, and then you can see in here with the compose compiler plugin. I know we talked about this a little bit, but as Seb mentioned, there's additional logic that's injected at the IR level. So this actually runs testing on how compose actually changes all that stuff and what it looks like in the end. So this is actually the human readable version of that. So you can see they injected their own composer. This is like the bit mask change. And then you can see these highlighted groups. Like this is like what causes the IR to like completely blow up. Yeah, so this is like really cool stuff. So if you want to, I think this is also, if you want to like know how like compose works and stuff like that, I would definitely start with running like their compiler plugin tests. But yeah, it's just really neat stuff. Like I said, compiler work is all poking and prodding. And yeah, and of course, like I would also recommend looking into how exactly they set up their testing, because they create their own like mini version of what you need to do in order to compile this stuff. So yeah, going back to the compiler configuration stuff, like there might be component registrars. So this is like the register extension, create compose IR extension. So that's what they're including for this test. Like that's what they're registering. And it's like, okay, so now we know that that's going to intercept some kind of default behavior for IR generation. So yeah, I think that kind of, there's not that, I don't know. I think we'll kind of leave it at that.
Yeah, it's a good point to wrap up, because otherwise we go even deeper into the rabbit hole, and then tomorrow we'll still hear, you're like, yeah, so if you do that, and then...
Exactly. Yeah, but yeah, thank you. I'm glad that we actually had a little time to run into some of that.
Yeah, that was great. And I'm very glad that I got to see some code that I hope I'll never have to look at in my entire life ever again.
Yeah.
Not because
it's not swing, you mean?
Not because it's bad, but it's because it's like, my brain is a visual brain. That code is an algorithms code, and that doesn't work with my brain at all. So I'm like, yeah, it's fine. I trust you. There's tests. That's fine for me. It's like, yeah,
That's
sure.
the only way. It's the only way.
The tests are green.
Glad that we have people that that want to do that. we need everybody. We need everybody.
Yeah.
That's what I say.
Yeah, that's really the lesson of all this. Like, compiler work is really best learned in a community setting. I've mentioned poking and prodding a lot, but also I think having your own notes. I mean, if anyone wants to even like contribute to the notes that I have ongoing on GitHub, I would love that. I think the JetBrains team is doing an incredible job with all the work that they've done already. They're just a very small team. So, you know, if other people want to pitch in, I'm sure they would just greatly appreciate it.
Absolutely. Amanda, thank you very much for being with us and explaining this, I would say, unexplored world, because to me at least is like, yeah, you know, I write the code and somehow it runs.
It
That's
just
not my
does it.
problem.
Yeah.
But I'm actually glad that someone is actually taking the time and making the effort of learning how it works and explaining it to us, because you know, you never know. One day you might need it, or one day you might find yourself that looking at, you know, the wrong side project that kind of lures you into this dark world.
Yeah, you know, I think no, I think this is something that can be useful for everyone, especially when you kind of make it way down in your career and all of a sudden you're like, oh, it doesn't quite do what I want to do, or we're working with a new library and it's just acting out. And you're like, why the hell is it doing this? And you just don't know where to start. And yeah, I would say this is a place to start.
Cool. So, Ivan, parting words besides.
Yes. No, but I'm very happy. And again, I think I remember something that they were telling us at university over and over and over. Don't try to optimize things because the compiler is smarter than you. Yes, it is. Also, the people working on the compiler are smarter than you. Don't try
different
to be
kind
fancy.
of smart. Different kind of smart.
Yeah. That's a given. But again, this was very, very nice, and it's one of those episodes that they will stay there, and then you can rewatch if you need it, because we talked about this. You know, it was one of those moments. I remember we talked about this thing at some point, and then you go to the content list. Okay, we have an episode. So. Thank you for being with us. Thank you for supporting us. I'm always remembering you. If you want to buy the keychain or the metal pin, just head on the coffee page that we have. If you want to buy the t-shirts, check the merch site. And if you want to subscribe for free, if you have an Amazon subscription, you can connect your Amazon gaming account to your Twitch account, and you can support us for free every month. And if you want to join the after episode chats that we have usually with guests, you can join the bruschetta tier on our coffee page. It's a monthly subscription, and you will have access to the Discord server and then the Meet chat that we have at the end of the episode. And yeah, thank you for the support. Thank you for being with us. If you're watching this on YouTube, please like and subscribe. And yeah. Thank you again, Amanda.
And yeah,
Thank you.
We'll see everyone next week when we have my boss as a guest. No pressure. We're going to be talking about the new UI in IntelliJ. So it's going to be more visual/UX kind of episode, you know, to balance out a bit. So that I can feel like I know what I'm talking about at some point. Thank you, everyone. Bye, Amanda. Thank you.
Bye.